Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so remember that log of mn. Do you remember what log of two things multiplied is? Remember what that is? Do you remember there's a property? This is the product property of logarithms. Remember what you do with those? Well, what happens when you do like go to exponents and it's like x squared times x to the third? What do you do with those exponents? Add them, okay? So it makes sense since logarithms are basically exponential expressions just rearranged. So this is log of m plus log of n. Do you remember that little property? Okay. And then the other thing we did was like, if it was like, here's example 1, example 2, log of m to the n. So this is a little different, right? Do you remember what you do with that? It's okay if you don't.
I will once you do that.
This guy gets thrown out there. So it's n times log of m. That's it. Okay? And then, of course, if it was division, m over n, it would be log of m minus log of n. Okay? There's another fun one. So now we're going to just use this to evaluate actual numbers here. So here, let's do example 1a is evaluate log base 4 of 16 x to the, and then 16x all parentheses to the third. Okay? Is this a little weird? Yeah, it's a little weird, but let's do it. So what's the first thing you want to do? You were going to use these properties that we just talked about. What do you want to do first? What makes sense to do first? Like, you're going to have these two functions. Which function in your gut do you want to do first? What comes first, multiplication or exponents? Exponents. So let's deal with that 3. What do you do with that 3? Are you just being shy?
Yeah, definitely.
So what do you do with that exponent? What do we do at the end?
Put it on the other side of the log.
Put it on in the front. So now we got log base 4 of 16x. Okay, so now what can we do with this 16 times x?
Can you go like log 16 plus log x?
Yep, that's exactly what you can do. So this,
do you just keep the 3 in front of the 1?
yeah, so this is 3 times this whole thing. So we need to put a parenthesis there. So we need to set a log base 4 of 16 plus log base 4 of x. Okay, does that feel all right? Okay. So now the last thing is, I didn't give you the whole problem. I want to evaluate this when x equals 256. Okay. So this was good. We needed to do that anyway, regardless of what x was. But if I would have given you 256 right away, you probably would have been tempted to put it in there, multiply by 16. Don't do that, because then you can't do this, which is nice. So now we're going to substitute 256 in there. So 3 times log base 4 of 16 plus log base 4 of 256. Okay? Can you guys remember how to do this? What's the answer to that? What's log base 4 of 16? Kind of thinking backwards, but do you remember, like, let's just do like 5 squared equals 25. So basically the log of 5 of 25 is 2. So this is just, the logarithm is just rearranging an exponential equation or expression. So basically, what exponent do you apply to 5 to get 25? 2. So what exponent do you have to write there to get 25? 2. So what exponent do you apply to 4 to get 16?
2.
2. Does that make sense, Delaney? Okay. What exponent do you apply to 4 to get 256? Let's see. 4 times 4 is 16. Times 4 is 24. Times another 4 is 256. So what's that?
I don't know how you do it.
Well, it's, I mean, 256, if you think about, I always think of it in terms of RAM. Like computers, it always comes in multiples of 4 or whatever.
Wait, but what if what if the base doesn't go into the?
Then it's a dumb question.
Okay.
And it's annoying. But it's gonna be fun. It's gonna be satisfying because look, I have 3 times 6 is 18. So the answer to this is just 18.
Oh, that's so much work to get that.
I know, but it's so satisfying when you can just get it to there. But yeah, so what exponent? So 4 times 4 is 16, times 4 is 64, times 4 is 256. Okay, use your calculator. You can do that. Or basically, you're not taking the 4th root, but you just keep multiplying by 4 until you get 256, and then count how many times you multiply by 4. Okay? All right, let's do another one. Let's do one that is a little more annoying. Okay, here's 1b. We're going to evaluate natural log of 7e squared. Okay, and that's it. So e is just that constant of exponential growth. Natural log, remember the base is just e, so that could be proved to be simple. But let's not worry about natural log and e at all. Let's just treat it like we did above. Same thing. So what do we do first? Bring the 2 over. 2 times the natural log of 7e. What do we do next?
What's the difference between natural log and log?
So natural log is just log base e. Okay? So if it helps to write it out like that, you can.
So it'd be 2 parentheses. Log. 7.
Uh-huh. Now I am going to do this. You guys okay with me doing that? Because what's this?
The same thing.
What exponent do you apply to e to get e?
0.
Nope.
1.
1. Okay, so that's 1. This is annoying, but guess what? You can put that in on your calculator. The calculator has a natural log button. Natural log of 7 will give you a number. And this is the number they give you. It is 1.95. Okay, that's just a calculator thing. It's annoying because it's not cute like 18, but 2 times 2.95 is just 5.9.
So how do you put that in on your calculator? Natural log.
Yeah, do you have your calculator with you?
I don't. What, is it on
You
my
can
phone?
do it on your
Is it on
iPhone.
my phone calculator too?
You can do it on an iPhone or Android as well. That natural log is definitely on a calculator.
I press the IN, so there. I have to press the 7 first.
You have IN, so it's LN.
Oh, that
Yeah.
one. Yeah.
So on an iPhone, you have to do the number first and then the function. But like on here, so natural log, where's natural log? Right there. So if I go natural log of 7, 1.95.
Is there the log is log in there too?
Yeah, so you have the regular log in there.
Like why is it times 10?
Because it's always base 10. So your calculator won't do other bases. Did you figure yours out? So you have the same as me. So there's your natural log. So just hit natural log 7, enter. That's it. Cool, huh? All right. So let's move on here to example 2. Example 2, we're going to use the change of base formula to convert a logarithm. Now, we talked about this a little bit ago, but change of base. So sometimes when evaluating solving logarithmic equations, the change of base formula is utilized. So here's the change of base formula. If I can read that. Log base b of x equals, oh my gosh, why do you have to write so small? I think they just want people to feel old. All right, log base b of x equals log base a of x divided by log base a of b. Okay, where a is the new base and b is the old base. Okay, so let's just try it with an example here. This is example 2a. I want to convert log base 100 of 10x squared to base 10. Okay, now our calculator, most calculators will only do log base 10. So this is good. We need this formula. So let's plug it in. So a is our new base. So we're going to say log. Oh, first of all, let's just do this. Let's just evaluate this to how it is. So 2 times the log base 100 of 10 plus log base 100 of x. Let's not do that. Get too far ahead. I don't know why they did it like this, but they're getting rid of the exponent because there's no exponent in here. So what they're going to do is they're just going to just do this. Okay, you guys okay with that? All I did was put the 2, and I still want to go to base 10. So now what we're going to do is plug this guy into this formula. All right. Okay. So this one is just 2 times log base 10 of 10x all over log base 10 of 10. Or no, 100, sorry. Okay, now on your calculator, the log base 10 is just log. Okay, so if you don't see a base, it's just 10, log base 10. Okay, well, we can do this. This is a subtraction problem, right? Because when you have 2 logs, no, That's not a subtraction problem. What are you doing? But we're gonna separate this. Well, what's log base 10 of 100? What exponent do you apply to 10 to get 100? That's just 2, right? Log of 100 is 2. Because log base 10 of 100 is 2. Okay, so then we got 2 times log of 10 plus log of x all over 2. Okay. Well, and it does give us an x. Evaluate when x equals 1,000. Okay. So log base 10 of 10 is just 1. Log base 10 of 1,000 is 3. You see what I did? All I did was plug in 1,000 there. So log base 10 of 1,000, what exponent do you apply to 10 to get 1,000? 3. 10 times 10 times 10. So that's just 2 times 2 is 4. All right, so now that we've explained it, let's do one from scratch. See if you can use this same change of base formulas. And again, on a test, if we do this, you can use this formula. And the test might say, use change of base formula to convert blah, 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 blah. Okay, here's 2b. Log base 4 of 2x to the third to base e. And then we're going to say x equals 6. Okay, so let's just get rid of that exponent first. So what do we do first? Let's pull that exponent out front. You guys okay with that? 3 times log base 4 of 2x. So far, so good? All right, now we're going to convert log base 4 to log base e. All right, so remember, this is the new one. So this is the new base. This is the old base. So we're going to say basically 3 times natural log of 2x all over natural log of 4. Okay, so remember b is the old base and a is the new base. And this base actually became one of the big letters. Okay, so log base 4 of x is equal to natural log of x over natural log of 4. Okay? Well, we can do this. You guys want to type that into your calculator? And then this is just 6. So x equals, so this is 3 times natural log of 12. I mean, we could do that. You could do natural log of 2 plus the natural log of x, or natural log of 6. Doesn't really matter, because you're going to get the same thing. So natural log of 2 plus natural log of 6 all over natural log of 4. Well, that's just plugging all those into your calculator. So that's going to give you approximately, when you plug natural log of 2 in, you get 0.6931. When you put natural log of 6 in, you're going to get 1.7918. All over, when you plug in natural log of 4, you get 1.3863. Okay, so that, once you evaluate all that, you get an ugly 5.3774. Okay, so this change of base formula is it's if you do it like 4 or 5 times, then you won't have to remember it. It'll be pretty easy, but keep it handy because you're going to have to use it. Just for the fun of it, what's the natural log of 12? Can you figure out what the natural log of 12 is? I'm guessing it's 3.4 something.
If you just click natural log and then 12,
Yeah.
it's 2.48.
Yeah, that's what I meant. 2.4 something because that's what that added together is, but you could just multiply 2 times 6 there. You don't want to do that with other things like this 10x. You don't want to go, well, I mean, I guess you could have because it was 10, but you could have just done natural log of, when you have other bases, it makes it a little bit more annoying, but yeah, okay. So last one is actually solving an equation. So let's just do that real quick, and then we'll be done with 87. I just erased the change of base formula. Oops. Now we have to remember it. So this is example 3, and we are going to solve 100 to the x power equals, or 1,000 to the x power equals 100. No, it's not x power. It's 9x. So disappointed with my eyes. Okay, so first thing, this is an exponential form. I want to write this in logarithmic form. So how do I write this in logarithmic form? Log of what? What equals what? Do you remember? Think backwards. How do I write it? Remember, the answer to a logarithmic expression is the exponent.
Yeah.
So this is 9x. Now what goes here and what goes here?
1,000 goes down.
Yep. Okay. So basically we're saying what exponent do you apply to 1,000 to get 100 after you multiply that, oh yeah, and then divide by 9, but let's not get that too far. So we're going to use the change of base formula to change this to base 10. This base 10 is nice. Natural logarithms are weird. Okay, so I'm going to change this to base 10. So we're going to go new base. So this is going to be log of 100 over log of 1,000. So basically, when you change it, you're just doing the new log here, and then it's just the big number over that old base equals 9x. Okay? Well, if this is base 10, what exponent do you apply to 10 to get 100? And what exponent do you apply to 10 to get 1,000? So 2 and 3 equals 9x. Now this is just a nice pre-algebra equation. Divide by 9, x equals 2/27. Let's see if that works. Yes, got it right. Okay, all I did was do the change of base formula here because any base that's not 10 or natural log is, you got to change the base. Okay?
What if the base is like 2?
Yeah, if you could do it, if you can figure it out, like, but we can't. We can't figure out what exponent we apply to 1,000 to get 100.
Right.
I mean, I guess you can kind of cube root it, and then square. I don't know, but it's just annoying.
Mm.
Okay.
So you just put those numbers. Okay, that makes sense.
You could figure that one out because a base 1,000 isn't terrible.
But a base 10 is easier.
Yeah, I mean, you don't have to do it that way. I mean, you could leave it in this, because really this is, okay, if I cube that, I get 10, and then I square it. So 2/3. The answer to this is 2/3 equals 9x, which comes down here. Now, you don't have to do the change of base formula if you can already figure out the answer. But yeah, it helps. Okay, so now that would have been impossible here, right? Because natural logs and all that is just crazy. All right, we're going to move on to 88. So this was a little bit longer just because it's all new stuff. This is stuff you've never done before. And, but yeah, if you need to watch the video again, do that. There's also some good tutorials in this new Saxon Algebra 2 book as well. Like you can just Google on YouTube, you can Google, if you don't like looking at my face, I won't take it personally. Okay, so 88. Here we go. We're going to solve abstract equations. We did this in Algebra 1. Abstract equations just means more than one variable. Okay, they make it sound confusing when they say abstract, but it's really not that confusing. It's also called a literal equation because when you solve it, you don't have a nice numerical value. You have an expression with other letters. So you're just rearranging an equation. It's kind of like when you clean your room and you move all your mess to one side of the room. Okay, but that area is clean. Okay, so it has two or more variables. Formulas are literal equations. All right, so let's just try with one that we're familiar with. What does this equation do? What does this equation do for us in real life? Do you recognize it? No? All right, well, you better. If you travel to any other country besides the United States, you need to know this. Yes, so this actually converts Celsius to Fahrenheit. But what if you're, like we did this in Nicaragua, like, okay, what should I set the air conditioner to? Because I'm hot and I don't know. So, but they only do Celsius. So, like, I think usually in our home, we set our air conditioner at the highest to 70 degrees, but we usually go like 68 or so. So I want to know how to do that with Celsius. So I want to solve for C. Okay? So what would you do to solve for C? What would you do first?
Get it. Well, I would add or subtract.
Yeah, so get rid of, just like you do in normal equations, C is almost by itself, and it's hanging around this coefficient. You divide by the coefficient last, so get rid of the constant first. And sometimes that constant could be another letter in these abstract equations. So then you got F minus 32 equals 9/5 C. Now what do? Now you divide by 9/5. Well, dividing by 9/5 is the same thing as multiplying by 5/9, right? So C equals 5/9 times F minus 32. Does that feel all right? Okay. So that's solving for C. This is a very, I mean, your iPhone can do that anyway, but
yeah, I found it in a different country. I can look up.
Yeah. So let's try another one. Let's do the formula for surface area of a right cylinder. This is the formula for surface area equals 2 pi r squared plus 2 pi r h. Okay. So I want to solve for h. I want to solve for h. So what do you want to get rid of first? Yeah, let's get rid of this other term. So this comes over here. So now we've got s minus 2 pi r squared equals 2 pi r h. Now what? Yeah, divide by everything being multiplied by there. So now you're dividing by 2 pi r, divided by 2 pi r. So that's what h equals. And I think they'll leave it like that. Yeah, they're good. So, I mean, I guess you could factor a little bit, but then you're left with that. So you would have like an s over 2 pi r minus r, because that would cancel to an r, but you can just leave it like that. That's awesome.
So these are just like getting one term on one side.
Yeah, you're just rearranging the equation. This is what other Mr. Flack loves to do. And so if they give you everything else, but what I like to do is just plug in all my numbers and then solve, because it's easier to rearrange an equation with all numbers in it than with other letters. But he likes to rearrange the equation first and then plug in the numbers. Whatever. Different upbringings, different people, different hair. Not really. Okay. So let's do, there's just a bunch of these. I don't think we need to do a bunch, but this is probably as complicated as it's going to get. So here's 2b. I want the height h of a free-falling object, neglecting error resistance, so don't account for that, is given by the equation h equals 1/2, fraction. Okay, do you know what these zero subscripts mean? Do you know that from physics? You probably know what the letters mean. So what's V stand for? If you're talking about height falling and, well, you know what H stands for, but what's H0?
Yes. Well, there's like HI and H0.
Yep. So HI and H0 are kind of the same thing, because H0 is initial height. So HI would be the same thing if you're using that variable. And this is the initial velocity. Okay. So solve for t. I just want to solve for t. Okay. Well, that makes it a little bit more complex, but this is a quadratic equation. So you know what we're going to do? We're going to plug this into the quadratic formula. And it's going to get real messy, but we can do it. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So this is our b. And this whole thing is our a. And this is our c. Okay? So to solve for t, it's just one quick motion. We just do t equals, oh wait, what's that, h equals? Oh, first of all, we need it to be 0 first, right? So we got to get rid of this h. So this is initial height minus height. So we just got to subtract that h there. So this c equals h naught minus h. That's what c is. So this is going to make it real messy, all right? But that's okay. -b, so negative initial velocity plus or minus the square root of initial velocity squared minus 4a, which is 1/2 g, c, which is h naught minus h, all over 2a. So 2 times 1/2 g. See how messy this is going to get? But don't worry about it. Just clean up as much as you can. Get rid of the parentheses. So -v naught plus or minus the square root of v naught squared. So this 4 and this 1/2 can cancel to a 2. And so you're just distributing this 2g over to the h naught and h. So minus 2g h naught minus 2g, or plus 2gh, because you're subtracting a subtraction. Isn't this messy? This is terrible. And then it's all over g. So that's your final formula for that. That was a pain in the butt, but that's what it is. Simplify as much as you can. Call it good. All right, that's about as complicated as it's going to get. I'll show you a few more examples and then we'll be done. Okay, so we're going to solve abstract rational equations. So let's say the total resistance is given by the formula capital R equals 1 over. Have you done any of these in physics yet? Have you done that yet? Okay, so we're going to solve for R1. Why not? Okay, so what would you do first? Any suggestions, recommendations? Well, this is a complex fraction. So you could get a common denominator and then copy dot flop and all that, right? So what's the common denominator? R1, R2, right? You just multiply them together. So this one needs an R1, and this one needs an, or this one needs an R2, this one needs an R1, right? Okay, so now we have R equals 1 over R2 plus R1 all over R1, R2. Remember doing those? Now copy dot flop. So R equals 1 over 1 times R1, R2 over R2 plus R1. All right, well, that's just this. So now we have to solve for R1. Okay? Which is problematic, but we could do it. So what do you do when you see a fraction in an equation? Quit. F-bomb. So let's multiply by the denominator. So we're going to multiply by R2 plus R1. And that will cancel it over here. And then this is just R2 plus R1 equals R1, R2. So we still have to get these R1s by itself. So we've got 3 terms on the board. So the next step is to get all our R1s on one side and then everything else on the other. So I'm going to bring this whole thing over here. So now I'm left with R2 equals R1, R2 minus R1. Okay? And then do you remember what you do here? We have to get R1 by itself.
That's R1. Can you divide by R1?
Well, we can take an R1 out, yes. So if we factor an R1 out, then we're left with R2 minus R. So far, so good. Now, how do we get R1 by itself?
By just dividing by R2 minus R.
Yep, so now we divide by this big chubby coefficient. So R2 minus R, that cancels, and we're left with this. So messy. So you won't get a lot of these, like on SATs and things like that, but you will get a lot of these reversing a formula type of thing. Okay, a formula for lateral surface area of a right cylinder cone is this. So here's a right circular cone. So the lateral surface area is given by this, pi r times the square root of r squared plus h squared. So remember, this is r, and then h is this. So how are they getting that? Well, the lateral surface area is this thing that's wrapped around, so you need to know that this length is. To do that, you have to use the Pythagorean theorem. So that's where this comes from, that square root. That's a Pythagorean theorem. So what we're going to do is we're going to solve for h. Solve for h. Okay? So the first thing I do is it's a radical equation. So let's get the radical by itself. To get the radical by itself, we're going to divide by pi r. So we got L over pi r equals the square root of r squared plus h squared. Now what do? What's your gut tell you? What do we do in a radical equation once we have the radical by itself? Do it. Do it. What do you do? Well, kind of. You have to get rid of that radical.
Yeah.
How do you get rid of a radical?
Do this.
Yep, square it. Right?
I got there, yeah.
Multiply it by itself or square it.
Yeah.
So that cancels that, and you're just left with L squared over pi r squared, or pi squared r squared. So you got this. Let's see how they wrote it. I just want to be consistent. Yeah, so when you square this, you get L squared over pi squared r squared. And then this is just r squared plus h squared. Last step, get rid of r squared. So L squared over pi squared r squared minus r squared equals h squared. Now how do you get h by itself? Square root. A lot of back and forth. But h equals the square root of L squared minus pi squared r squared minus r squared. Messy, but that's it. Okay? Yeah, and then there's one more application for a cylinder, aquarium, same kind of thing. I'm just going to do it real quick. Volume of a cylinder is just pi r squared h. That's the volume of a cylinder. Okay, if I want to solve for r, then get rid of everything, get rid of these two. So I'm going to have r squared equals v over pi h. You see what I did? Now square root both sides. And there's your answer. So r equals the square root of v over pi h. All right, and then it says 25 meters, or it gives us numbers, and then we can plug in those numbers and solve it. But again, I probably would have plugged in all the numbers and then got solved for r. So you don't have to do it this way. If they give you the numbers of all but one variable, you can plug in all those numbers first, or you can rearrange your equation first. Doesn't matter. Okay, you guys good?
Black math, give me some math and I'll give you some flack. Black math.